Good morning, students. Today we will discuss how to write material balance equation in case of mixing. That means material balances we are dividing into two categories here, two parts. Like in the first part we discuss material balance without chemical reactions. In the second part, material balance with chemical reactions. So now under the topic of without chemical reaction, three unit operations we are going to discuss: mixing, evaporation and distillation. Now we will solve a problem in mixing. Mixing is unit operation where there is no chemical change, only physical, simple mixing, that's all, only physical changes. So mixing, first we will read out the problem carefully. The waste acid from a nitrating process containing 20% HNO3, 55% H2SO4 and 25% H2O by weight. By weight is important. Whenever percentages are given, you need to check first, is it by weight, by moles or what? Is to be concentrated by addition of concentrated H2SO4 containing 95% H2SO4 and concentrated HNO3 containing 90% HNO3 to get desired acid containing, this is the desired acid, means product acid, 26% HNO3 and 60% H2SO4. Calculate the quantities of waste and concentrated acids required for 1000 kg of desired mixed acid. Okay, so here we are reading the term here, waste acid contains three components, actually two components, that is the rest is water. On the whole, three components are there in that solution. So 20% HNO3, 55, they are saying waste acid. Actually nothing is waste strictly speaking. Why they are saying waste acid is from many chemical industries, especially from fertilizer industries, liquid waste contains some acid, some quantity of acid. From fertilizer industries, liquid wastewater contains some amount of acids, that is say HNO3, H2SO4, like that. That for that particular industry it is waste acid, but it can be strengthened by the addition of concentrated acids. That is why newspapers also we see waste acid available, or another term we use for that is spent acid available, like that, you know. And some chemical industries we get this spent acid. Spent acid means a dilute acid, like aqueous solution contains little amounts of acids. So what they do, some small entrepreneurs, they purchase the spent acid from them and then they increase the strength of the acids, that by the addition of pure acids. That is like a small business for them. So here the spent acid or waste acid contains HNO3 20%, 55% H2SO4, the rest is 25% by weight. Now this is to be concentrated, means it is necessary to increase the concentration of HNO3, increase the concentration of H2SO4. How to increase the concentrations? By addition of pure H2SO4. Pure means it's roughly between 90 to 100 only, anyway. So by adding 95% H2SO4 and 90% HNO3, then the product acid what we will get after adding these concentrated acids, that we are calling it as desired acid. Desired acid is nothing but product acid, product containing, and the composition of this product acid also is given, that is 26% HNO3, 60% H2SO4, the rest is water. Calculate the quantities of waste and concentrated acids required for 1000 kg of desired mixed acid. So actually when the engineer wants to prepare 1000 kg of product acid, 1000 kg of product acid, he needs to calculate before starting the operation only how much of the spent acid he has to take it and how much of concentrated acids are need to be mixed in order to get 1000 kg of the desired mixed acid. That is the problem. So this problem we solve by, we start the solution by drawing a small diagram. Just like a block diagram we will draw. Just after seeing that block diagram, you will know the complete problem. Okay, this is mixing. Now, what are the inputs to this? Here, this is waste acid, also known as spent acid, and here concentrated H2SO4 and another acid concentrated HNO3. We are adding waste acid and two other streams, concentrated H2SO4 and concentrated HNO3. Then the product acid, this is product acid, or we also call it as desired acid. Okay, like this. Now what compositions are given? This waste acid contains 20% HNO3, then 65% or 55% H2SO4, and then 25% water. If you add, you need to get 55, 60, 80, 20, 100%. Okay, this percentage is all by weight only. Now, to this concentrated H2SO4, 95% H2SO4. Okay, and this is 90% HNO3. Okay, this is the problem. Spent acid containing HNO3 20%, H2SO4 55, water 25%. This is mixed with concentrated H2SO4 containing 95% H2SO4 and concentrated HNO3 containing 90% HNO3. All these three streams are mixed to get the product acid, and the product acid composition is also given. Product acid composition is 26% HNO3, 60% H2SO4, 60% H2SO4. Okay, so this is the remaining 14% is water. Sometimes they mention water percentage, or if it is not mentioned also, we can add these two and separate from 100, you will get 14. So now the question is, to prepare 1000 kg of product acid, what weight of spent acid is to be mixed with what weight of concentrated H2SO4 and what weight of HNO3? That is our question. So this type of questions can be solved by writing material balance. What is material balance? Material balance or mass balance, we can say. Material balance is mass input equal to mass output. Okay, this is material balance. means the total mass input must be equal to the total mass output. That you can say this arrow marks here into this box is the unit operation. Here the arrow mark towards this indicates input. So here 3 inputs are there, 3 streams are there under this input, 3 streams. The sum of all these streams should be equal to the output. Output, this arrow mark, if you observe, it is leaving out. So this is output. Here under output only 1 stream is there. Under input here 3 streams are there. So the sum of the input must be equal to the sum of the output. So this is actually based on the law of conservation of mass. According to the law of conservation of mass, mass can neither be created nor destroyed. So whatever the mass is there, that will be there here. So here some HNO3 is entering here, some HNO3 is entering here. The total HNO3 entering must be equal to the total HNO3 present in the product acid. Similarly, H2SO4 entering here plus H2SO4 entering here must be equal to the H2SO4 in the product stream. Like that. That is the mass balance. So now we will assume what weight is of each stream are entering. Let weight of spent acid is x kg, what we have mixed, and weight of concentrated H2SO4 is y kg, weight of concentrated HNO3 is z kg. That we will assume first. So this is x kg and this is y kg and this is z kg. Okay, x kg, this stream y kg, this stream z kg. Let all these xyz streams are added in order to get 1000 kg of the product acid. So now we shall try to write the material balance. So material balance we can divide into 2 main types here. One is the overall balance and the other is a component balance. What is meant by overall balance? Overall balance. The term indicates overall means on the whole what is the balance. Means we don't look into the each component. We try to look at the total quantities only. That is the overall balance. Here the total spent acid entering is x kg. This x kg includes all these 3 components. And here y kg of concentrated H2SO4. That means here what? The remaining water is there here. So this is y kg is total entering and here z kg total is entering. So overall balance is x plus y plus z. The total mass input is x plus y plus z. That must be equal to the total mass coming out, that is 1000. This is equation 1. Okay? That is the overall balance. On the whole we are writing total weights we are writing. We are not taking separately each component. Next, component balance. Next is component balance. Here, how many components are there here? Component balance. How many components? 3 components we can say. One is HNO3, H2SO4 and water. So H2SO4, then HNO3, water. 3 components are there. So for each component you can write the balance separately. Means how much H2SO4 is entering? Total. And then how much H2SO4 is leaving. That is the H2SO4 balance. Similarly for these 2. So how many equations you will get? 1, 2, 3. One more we have here. So total 4. But how many unknowns we need to solve? Only 3. To solve 3 equations are enough. So we will write the component balance for H2SO4 and HNO3. You will get 2 here and 1, 3. Then we solve for XYZ. And water balance we can use for checking whether our answer is correct or not. So H2SO4 balance. H2SO4 balance we write. Okay. So what is the H2SO4 balance? First we shall write in words. H2SO4 is present in spent acid. H2SO4 in spent acid plus here whatever H2SO4 is present in this stream and here in this stream also H2SO4 is present. H2SO4 in concentrated acid, this one, that's all. Here there is no H2SO4, this is purely HNO3. So H2SO4 here plus H2SO4 here, this must be equal to, this is the input, total input equal to output, that is H2SO4 in product acid. In product acid. So this is material balance for H2SO4. Okay, material balance for H2SO4. So what is H2SO4 in spent acid? H2SO4 55% of X. That this is 55% of X is H2SO4 in spent acid. 55% of X is H2SO4 in spent acid plus H2SO4 in concentrated acid. How much? 95% of Y. That is 95% of Y here. Okay. That must be equal to H2SO4 in product acid. How much? H2SO4. 60% of total is 1000 kg. Okay. This is H2SO4 balance. Here 95% H2SO4 means the remaining 5% is water. Okay. Water is also there. So now you can easily do this, that is 0.55x plus, once this is clear to you, the rest for the remaining components you can write very easily. So 0.55x plus 0.95y is equal to 0.6 into 1000, that is 600. Okay. Let it be equation 2. First equation, overall balance, x plus y equal to 1000. This is the second equation. Now, HNO3 balance. HNO3 balance. HNO3 balance, again, HNO3 in spent acid plus HNO3 in concentrated acid is equal to HNO3 in product acid. Okay, HNO3, whatever HNO3 is there here in the spent acid plus HNO3 in the concentrate, these are the inputs. This input and this input. Sum of these two is the total input. Output is HNO3 here, 26% of 1000. So this is HNO3 spent acid. HNO3 percentage is 20%. So you can write now as 0.2x plus HNO3 in concentrated, that is 90%. That is 0.9 into y here, not y, z then. Okay. The total weight of concentrated HNO3 is z kg. So 0.9 into z is equal to here HNO3 26%. So 0.26 into 1000, that is 260. Let it be equation 3. This is 0.26 into 1000. Okay, like this now we wrote for our two components, component balance H2SO4 and HNO3. So now 3 equations are there, 3 unknowns are there. So solving all the 3 equations, you will get XYZ values. Solving equations 1, 2 and 3, you will get XYZ values. X is equal to 400 kg, X equal to 400 kg, Y is equal to 400 kg, Z is equal to 200 kg. This is what we got. Okay, then we want to check our answer is correct or not. Z is 200, X and Y 400. Our answer is correct or not. Then what we will do? We write the material balance for component water. Checking for water balance. Checking for water balance. So what is, how to write water balance now? So water is present in spent acid, water is present in this concentrated H2SO4, water is present in concentrated HNO3. So water in spent acid plus water in concentrated H2SO4 plus water in concentrated HNO3. In all the 3, water is there, is equal to water in product acid. Water in product acid. So water in spent acid, how much? 25% of X, that is 0.25 X, plus water in concentrated H2SO4, 5% of water, that is 0.05 Y, plus here 10%, here 90% HNO3, no? So the remaining 10% is water. So 0.1 Z here, total is Z, is equal to here 1000 into 0.14, that is 140. This is 1000 into 0.14. Okay, this is let it be equation 4. Now substitute XYZ here. Substitute XYZ. So 0.25 into X is 400 is equal to 140. This whole thing comes to 140. This whole thing comes to 140. So 140 is equal to 140. Thus LHS equal to RHS. That means your XYZ values are correct. Okay. So now you can conclude the answer. You can conclude the answer by writing spent acid spent acid, that is X we assume, X is 400 kg, then concentrated H2SO4 is also 400 kg, then concentrated HNO3 is 200 kg. So these weights if you mix, you will get 1000 kg of product of that desired acid. So the engineer calculates like this. This type of calculations they do, and then according to this they will add what weight of spent acid to be added to what weight of concentrated H2SO4 and so on. Thank you.